Hello, I'm Renato Figueiredo with the University of Florida in the FutureGrid project, and I'll be your instructor for the course on IPOP, Network Virtualization in Infrastructure as a Service Cloud Computing. This material is based upon work that has been sponsored by National Science Foundation, and in this first unit we're going to introduce virtual machines, virtual networks, and their context in cloud computing. So beginning with the basics, what is cloud computing? One definition that comes from NIST tells us that cloud computing is a model that enables on-demand access to a shared pool of configurable resources. And I'm highlighting here keywords that are going to motivate the work that encompasses this course, which is on-demand, shared, configurable network servers and storage. So infrastructure as a service is a model, or IaaS for short, is a model where cloud computing allows you to pay as you go when you access resources over networks. And the benefit of this is that you can create resources that grow or shrink depending on demand. And that's important if you don't know the demand of your workload a priori. For example, if you have a small company and you have a number of web servers that you need to deploy today, if you become successful in a few days or weeks, you may need to scale those services considerably, and cloud computing provides that type of elastic capacity. Now, at the core of cloud computing technologies is this approach of resource virtualization. And that's a recurring theme in this course, and in particular in the network subsystem. But virtualization is a general approach that applies to major subsystems of your typical computer. The server itself with virtual machines, storage with virtual file systems, virtual disks, and networks with different types of virtual network technologies. And in this course, I will present a particular kind of virtual network. But virtualization is what allows cloud computing to be done on demand in a way that allows users to share infrastructure in a configurable fashion. So one key technology behind cloud computing is virtual machines. They essentially paved the way for systems like Elastic Cloud, Amazon's Elastic Cloud Computing, or EC2, basically by allowing users to see an environment for computing that's decoupled from the physical infrastructure. And that allows providers to create computing environments for the users and enable the users themselves to configure these environments. And that's very different from a model where you don't have a virtual machine, where you have operating systems and users are constrained by the operating system version, libraries, etc. that are provided to them by a hosting service. So virtual machines began as a niche market. They actually date back to the early 70s, but when they resurfaced with products that targeted commodity servers, they began to pick up steam, and now they are mainstream in a variety of applications. Now, in this course, I'm not going to cover virtual machines in depth, but I would like to draw a contrast and comparison with virtual machines and networks so you can understand the relationship and how virtualization underlies these technologies. One issue with virtual machines is that they end at the server's boundary. A virtual machine works well within a server, but when a server needs to communicate with other servers, the virtual machine itself does not provide a lot of support. And cloud computing means many virtual machines that are distributed. So you need to communicate among these virtual machines, and communicating directly over the physical network has several constraints. So virtualization again provides us with isolation, security, and resource control in the network, and that's the topic of this course. But to give you contrast with classic virtual machines, again, they provide this ability for you to create an environment that's isolated from the physical server. It's a duplicate functionality of the physical server, which means you can run the same kind of software inside of them, and they are efficient, which means that they run at almost native performance. And these are technologies that again date back to the early 70s in the context of mainframes and have found a resurgence in commodity desktops and servers. But the key abstractions for these virtual machines is they intercept instructions, for example, a CPU instruction or an I/O device instruction, and instructions that access memory. And then they interpret these instructions inside the virtual machine. So suppose you're a resource provider and you have computers that you want to allow multiple users to access with their own environments in a way that they are isolated from each other. With virtualization, what you do is you run a piece of software called a virtual machine monitor on these resources, and these VM monitors could be VMware, VirtualBox, KVM, Hyper-V, Zen, and there are other kinds of systems available. But they essentially provide this layer that isolates what's running inside the virtual machines from the physical machines and from each other, and at the same time multiplexing the resources on the physical resource. Time sharing the CPU cycles, space sharing, memory, and storage. From the user's perspective, they are given virtual resources that look just like the physical resource but has fewer capacity, less memory, a little bit less CPU, etc. And the nice thing about virtualization is the user is able to configure these resources on by themselves. So a user A could run a version of Linux, Ubuntu, while a user B uses a different kind of Linux distribution, and user C uses a virtual machine that has the Windows operating system, as an example. So this is very nice and important for cloud computing, but what happens when you put multiple of these resources together is you need some type of software that manages a pool of resources, and that's the infrastructure as a service cloud computing stack that you normally find in systems like Amazon EC2 or open source systems like OpenStack, CloudStack, or Nimbus, or Eucalyptus. Now again, these systems provide the basic ability to create and manage virtual machines, but when it comes time for virtual machines to communicate with other virtual machines in the cloud, you need something beyond the virtual machine monitor, beyond the infrastructure as a service software. You need a virtual network. So some examples of usage of virtual networks in IaaS. Suppose you have multiple users in the same provider and you want to provide these users with guarantees that their traffic is isolated from other users. They may have sensitive data. They would not like other users to access information. And network virtualization provides a basis for enforcing isolation across multiple network flows. Another example could be you have virtual machines that are running on a commercial cloud provider, but you also have a local infrastructure in your enterprise that you would like to run for your workloads. So with cloud bursting, you could run workloads locally in your enterprise and not pay the price of running instances on a commercial provider, but when you need the extra capacity, you can provision resources on the cloud and attach them to your local enterprise as if they were additional resources that you just connected to your data center. Having a virtual network makes this process seamless and allows you to connect resources as if they were part of your local area network. Another example would be a federated environment where you have multiple institutions who are working together in shared resources across multiple domains and providing them in a way that from the perspective of a user, they look like a logical set of resources that could be functionally equivalent to a cluster that they have in their local computing facility, but they're in fact distributed across a virtual private cluster. Now, virtual networks then need to allow many virtual networks to share an infrastructure. You could have a virtual network per user, per application, per project. You need that kind of flexibility, just like you need the flexibility of running many virtual machines on top of a single physical resource. It's also important for virtual networks to be independently configured. For example, you would like for your network, for your project to have its own address space if it's using TCP/IP, for example, private address space that is independently configured with addresses and configuration for endpoints from the networks of other peers sharing the same resources. And finally, you need to multiplex the physical network resources. At the end of the day, information needs to communicate through the physical network, but you'd like that to be done with isolation. So your messages are not conflicting with messages of other users, and in fact, isolation can be enforced with privacy if you use technologies like virtual private networks. And sharing here includes network interfaces at the virtual machines themselves, and the physical machines, and the switches and routers, and the network fabric that connects the hosts of these virtual machines together. So when you have virtual machines and virtual networks, your virtual infrastructure becomes quite flexible. Here we have an example of a physical infrastructure with 3 providers, domains A, B, and C, and this virtual infrastructure V2 is instantiated with virtual machines across multiple of these providers. But they look, when put together, they look like a virtual private cluster with its own private address space and with the functionality equivalent of a local area cluster. And if you deploy multiple clusters on other resources in the same domain or other domains, they also behave as independent virtual private clusters that are isolated from each other. In fact, they could be from different users or for different applications from the same user, for example. So in the rest of this course, I'm going to focus on what is needed to enable this from the perspective of a virtual network. Virtual machine monitors are already covered in other modules, and in particular, I'm going to cover a virtual networking technology called IPOP that provides certain interesting properties when you put together these virtual private clusters on cloud computing systems. So that's for the next unit. Thank you.